Today we're going to look at some more log laws. Last lesson we learnt about the sliding base. Today we have 3 more log laws to learn about. If we have got log base A of 2 things times together, then you can change that to be log base A of x plus log base A of y. Law number 2, if you have log base A of 2 things divided, then you can split that to be into 2 logs that are going to be subtracted. And it's log base A of the number on the top, which is the x, minus log base A of the y, which is on the bottom. And the third law is that if we have log base A of x to the power of n, that you can bring that little power down to the front of the logarithm. Some useful rules to memorize are also here below. Log base A of a to the power of x is equal to x. Okay, now that's a very useful rule, and it's actually easy to prove as well. If I was to use my third law that we just discussed, I could bring the x down to the front of that logarithm. So it would be x log a of a. And we know that a to the power of 1 is a, so that log would just be equal to x times 1. So it's just equal to x. So that is this rule, the first rule here. Then we have another one. A to the power of log base A of x is going to be equal to x. So what that is saying, as long as the base of my exponential here and the base of my logarithm are the same, then they are going to cancel each other out and I will just be left with the x. So let's practice using a few of these rules. So example number 1, simplify log base 5 of 5 to the power of 6. Now we can practice law number 3 here, and we can bring that 6 down to the front, and that would give log base 5 of 5. Now if you have the same base as the number on the end, then that logarithm is just going to become 1, and 6 times 1 is simply equal to 6. This question could also have been done with this little shortcut here. As long as the base and that number there are the same, then it's just going to be equal to whatever the power is, which is the 6. So let's use the shortcut for the second one. If I have 4 as the base, and I have 4 as the base of the logarithm as well, 4 to the power of log base 4, they're going to cancel each other out, and the answer will simply be the 21. That is using this second law here. Okay, question 2. Given that log base 5 of 3 is approximately equal to 0.68, now we're given these values because we can't do any logarithms on our calculator unless they have a base 10 or a base e. So we've been given these approximate values so that we can do these calculations. So log base 5 of 3 is approximately equal to 0.68, and log base 5 of 4 is approximately equal to 0.86. So find log base 5 of 12. What we want to do is take this number on the end of our logarithm here, and we want to change it into another mathematical sum, either multiplying, dividing, something like that, that only involves 3, 4, and also we can be sneaky and we could also use 5 because we have a base of 5 in there. But we're mostly trying to break it into 3 and 4. So 12 can be written as 3 times 4. So I'm going to change that log to be log base 5 of 3 times 4. Now that means that I can use law number 1. If I have 2 things multiplied, I can change that into 2 separate logs that are added. So log base 5 of 3 plus log base 5 of 4. Now we are given some values that we can sub in for those. Log base 5 of 3 is approximately equal to 0.68, and log base 5 of 4 is 0.86. So altogether, that makes 1.54. So let's try that again for part B. I have log base 5 of 9. So that 9 on the end, I need to try and write that in terms of 3s and 4s and maybe 5s. So 9 is 3 squared. So let's change that to be log base 5 of 3 squared. Okay, we could do 3 times 3 as well, but 3 squared gives me an opportunity to use my third log law. So when I have a power, the third log law says I can bring that power down the front. So that's going to be 2 log base 5 of 3. Log base 5 of 3, we've got that highlighted over here, that's equal to 0.68. So I just need to go 2 times 0.68, which means that that log is equal to 1.36. Part C, we have log base 5 of 0.75. Okay, so remember 3s, 4s, and 5s is what we want to try and use here. So the decimal 0.75 is the same as the fraction 3 over 4. Okay, so we have log of two things divided, which means we can use the second law to change that to be 2 logs that are subtracted. So that's log base 5 of the top number, which is 3. Then you do minus log base 5 of the bottom number, which is the 4. And we can sub in. Log base 5 of 3 is 0.68. Log base 5 of 4 is 0.86. And we get a negative answer, negative 0.18. Part D, log base 5 of 60. So we're looking for 3s, 4s, and 5s that we can use to make 60. Well, it turns out that 3 times 4 times 5 makes 60. So log base 5 of 3 times 4 times 5 does make 60. So I can use law number 1. I can change that into logs being added. So that's log base 5 of 3 plus log base 5 of 4 plus log base 5 of 5. Log base 5 of 3 we know is 0.68. Log base 5 of 4 is 0.86. Log base 5 of 5, we haven't used this one yet, but we know if the base and the number on the end are the same, 5 to the power of 1 makes 5, so that logarithm is going to be equal to 1, so plus 1. Altogether, we get 2.54. Question 3 says to use log laws to expand. So we won't be able to get a numerical value for these, but we can practice using our laws to expand these out. So I have log base 4 of 5 times x cubed. So because the 5 is times with the x cubed, I can use my first law to split that into 2 logs that are added. So log base 4 of 5 plus log base 4 of x cubed. Now I can't simplify the first log, but the second one with that power of 3, I can bring the 3 down the front to be log base 4 of x. And that is all I can do for this question. So let's try again for part B. Log base 7 of 7 over x. So they are 2 things that are divided, so I can turn that into 2 logs that are subtracted. Log base 7 of 7 for the top number minus log base 7 of x for the bottom. Then log base 7 of 7, these numbers are the same, so that means that that log is going to be equal to 1 minus log 7 of x. And that's it. That's our little introduction to the 3 log laws. You need to practice exercise 8D.